Hi there folks, Root Beer here. I thought I'd show you another little bit about constructible numbers. So in the last video, well 2 videos ago, we introduced constructible numbers. They're basically starting with our good friend 1, the unit length. We assume that's constructible, that somebody has handed you the unit length. Constructible numbers are really, with straight edge and compass, what other numbers can we construct as a given length. Okay. So I showed you how to do 2 and 3 and 4 and those sorts of things. And then in the last video, I showed you if you start with 2 constructible lengths, little a and little b, you can get a plus b and a minus b. And then I fudged around with the diagram as I try and do at the end of these videos. And it got angry at me. But you'll notice in the last video, when we did a plus b and a minus b, we learned that you can get a plus b and a minus b from given constructible lengths. If we assume a and b were somehow constructible from our unit length, you could get a plus b or a minus b. And we showed how to construct that. But we didn't use our friendly unit length, which I'm now get rid of that point. We didn't use our unit length that we were given. You don't need that for the a plus b. Okay? So if you are given non-constructible lengths just out of thin air, a and b, and you can get a plus b and a minus b. But the video today, where we talk about a times b and a divided by b, we're going to have to use that this 1 has been given. Okay? But we're going to get a plus b, or no, sorry, not a plus b, a times b and a minus b. I'm thinking about other things. We're going to get a times b and a divided by b. In this video. The same technique, it's going to use similar triangles. And then, so that'll, starting with the integers, if you can do a divided by b, if I can get you a and b as integer lengths, 2 and 3, then we can construct 2/3, that sort of thing. Okay? And then we'll have one more video after this where we do the square root of a given length, a given constructible length. And so that'll be nifty, and then we can get, square root of 3, that sort of thing. Okay. But enough dilly-dallying, let's actually get into it. Suppose we were given an A and a B as given lengths, and I want A over B and A times B. So we're going to construct similar triangles, and we're going to have this 1 here. He's going to help us. So we have A and we have B. Okay, it doesn't matter which length is which in terms of longer or shorter. I know in the last video to do A minus B you had to sort of assume that B was the shorter one. But no need for that in this video. So what are we going to do? Well, what we're going to do is we're going to sort of just reproduce A at any angle from the 1. Okay, and if we need to, we'll sort of do it. So I like to imagine that my lengths are just given to me randomly, and they're just sort of any shape haphazardly. Some people doing this construction might start with the A and the B in the proper position, but I like to show that we can get them in the right position. So we're going to create similar triangles. I'm going to get one triangle with 1 and A, and I'm going to get another triangle with 1 and I'm going to get another triangle with B and then A times B. Okay. But in order to ensure that we get a triangle, I'm going to translate this A so it meets up with the 1, but I want to get an actual angle. I don't want them flat against one another, so I'm going to make them right angle triangles. Okay. So, get a line segment here, and we're going to get A there. So, I want parallelogram. I want to get this A length down around here. So how do we do that? Well, parallel. Oh, no, that's not the one I want. We want a parallelogram, but I was starting with the wrong thing. It always goes from the common vertex, is my technique. Okay. There we go. perpendicular line here. Intersects the circle we started with. Then we get the other chord, or the other end of the chord, and we just extend that line. Okay. One parallel line down, one to go. Oops, we needed that one. The other points we can hide. There we go. Alrighty. So we need one more parallel length. Okay, so now, where am I at? I'm a little scatterbrained right now just because I thought I could make this video before I started getting hungry for lunch, and this is not the case. Alright, so now we extend this line here, and that's parallel, so we get our parallelogram. Fantastic. So this point is the same as length little a, and now we're going to make a perpendicular line off of the 1, and then we're going to translate our a, rotate it so that it lies on that line. So many extra lines and circles that we don't currently need. There we go, and we take this length and we copy him. Okay, so now this length here, this side of our right angle triangle is the, oh, hello, you're in a little extra point that I've missed in my hiding. He's the same as A. Didn't even show that. Yeah, he really is the same as A. Okay. So we're going to get a 1 and an A, and then we're going to sort of translate our B down here and make another right angle triangle. And so 1 to A is going to be the same as B to this this other length. So what do we do to go from the two? We multiply both lengths by B, and so this length up here will be B times A. Okay, and so that'll get us B times A. How do we get A over B? Well, we will also construct a right angle triangle. We'll get sort of 3 right angle triangles in sequence, but we'll get one with B and A, and then when we extend that up to 1, that's like dividing by B, so the further one will be B over A. In fact, just based on what happened with my A plus B and A minus B, because when I fiddled them around at the end, it sort of lost its focus. So I'm actually going to have the right angle triangles in separate positions, so they're not overlapping in any weird way, and we'll be able to see what's going on. So now both of these lengths are A. Okay. So what do we want to do? Well, we want to get B down here right up against 1, or we'll actually put it on the other side as 1. I don't know. I'll figure that out in a little bit. So more parallelograms to the rescue. I know we love doing this. That's why a lot of people, if they're going to do this, they tend to start with the lengths where we want them to and just show. There we go. and just show that the similar triangles work out. But I feel like you really should be doing the whole construction. Because otherwise you're just talking about similar triangles, and it's more a geometric, it's more of a picture proof rather than a construction proof. And I feel with constructible numbers we should be constructing. Okay, that point right there. There we go, parallel line. Okay, so we'll clean that up, and then we got another parallel line we've got to make. Okay, intersection points here and here. Where it intersects the original line. Circle, get the other end of the chord. And there we go. Okay, so now let's clean up a little bit. Far too many dots just hanging about on our picture. Do have to be careful though, I don't want to get rid of a dot that I have already placed with these A's here. Do we have any hidden extra dots really far out? No. Alright, so now we've reproduced the B length. I feel like, because I want to see where B is, I'm going to put the B length over on this side. So we're going to sort of have 4 triangles all together, and we'll just talk about how they're similar triangles. Yeah. Okay. So, one of the triangles that we're going to need, as I clean up here, this length really is B. Moves just like B does. So one of the triangles that we're going to need has AB. It's sort of the AB triangle. And then using the 1, we're going to opposite, we're going to get a parallel line, we're going to create a triangle with 1, and then it'll have to be A over B as the other leg. And so the other one that we're going to need, so I'll do the lavender and the dark purple for those ones. And I will do, what's good? Brown and red for the other one? Yeah. So the other one we need to do is connect up one and A. Okay. So now we're in the business of more parallel lines. Okay. So we need line parallel to this one, AB here. Okay, and running through this the end point of 1. Okay. Seems like it's always parallel lines. You want to reproduce a length, got to make a parallelogram. You want to make similar triangles, you're going to have to get parallel lines so you can ensure that they have the same sort of angles. Alright. So now we have our length here, and that's going to intersect at this point down here. So now I can clean up a bunch of this. And so that's going to be opposite my lavender. line, so we're going to get the deep purple segment. And now we've got two triangles here. We have a base of B and a base of A, or a base of B and height of A, and with similar triangles, and they are similar triangles because they both have the right angle, they both have parallel lines, that sort of thing. So base of B is to base of 1, as height of A is to height of A over B. Now because B is less than 1, this length gets bigger than the A length, but as soon as B is bigger than 1, suddenly he shrinks. And if it's equal to 1, well, wouldn't you know it, it's the A length again, because A over B, A over 1 is just A. Okay? So now we got those similar triangles. Now the brown, and I said red, but I've already got red here, so I'm going to use orange. Not that it particularly makes a difference. Okay. So we need similar triangles. So we've got the 1 to A, and now we need this to go through our B length down here. So we actually didn't need this guy at all. But I'm gonna keep him there because then I can compare and say when B is equal to 1, look at this, isn't it a nice diagram? Anyway, let's get back to it. This is our last parallel line. This is going to be the last thing we need to do, actually. And there it is, and then it intersects down here at a length known as A times B. Okay, so we can clean all of this up. We got our final point that we wanted. So one of these points was the duplicate of A. But now, with our segment tool, we can use the orange. And there it is. So we've got 1 to A is the same as B to this length here. So it's got to be B times A. So if I drag my B down here to be 1 again, you notice when B is 1, the B times A and the B divided by A length. By the way, they're not the colored lengths, they're the heights of these, the downward facing triangles. Can make that a little clearer, can't we? They start to converge on this A point here. So this orange length, we'll talk about it, I'll highlight it with a green length. So right now, this green length here is A times B. Okay? As B gets close to 1 in the same length, this middle dot here represents the length of A. Remember we brought that down? So as B is less than 1, A times B should be less than A. When B is equal to 1, you get A again. When B is much bigger, A goes off the charts, or A times B goes off the charts. And you notice it isn't impacted by A. Okay, the relationship, it's all about the B, the order of these three. So now, let's get the green length here for the smaller purple triangle. Now the green length is A over B. So A divided by something bigger than 1, it's going to be less than our little A marker there. If you divide by something less than A, suddenly A over B shoots up. And a proof of why this all works, just similar triangles, the way we constructed it. Okay. But notice once again, it's all about B that determines the order of these points. Okay, the middle point is our A over B, A times B. The A doesn't change the order, but the B certainly does. I think that's pretty cool. So we'll get rid of those. And yeah, that's it. So that shows you how to construct A times B and A over B with given constructible lengths, or really just given lengths, provided you have the length, the unit length that we always assume is constructible. So that's A plus B, A minus B, A times B, A divided by B. We just have root A left to go, and that'll be all the basic constructibility angles, or not angles, constructibility operations is the word I want. And that'll be it for constructible numbers. So thanks for watching, and join me for constructing root A from a given A in the next video.